This is Trig Identities part number 15, and I wanted to cover Ptolemy's table of chords a little more in depth. Why? Because we're going to use Ptolemy's table of chords to disprove what we were trying to disprove in Trig Identities part 14. Okay. Now we're going to start with a few things. Just like in Euclid and these proofs, we got to start with a few things. Given this is a unit circle, what did I tell you about unit circles? I told you that in a unit circle, the radii are always equal to 1 of something. It doesn't matter what unit of measure you use. Miles, kilometers, centimeters, millimeters, doesn't matter. As long as that radius is 1 of something, you've got yourself a unit circle. Okay. Now, this radius is 1, this radius is 1. This is a 60-degree angle. At least that's what we're going to tell you right now. This is going to be a 60-degree angle right here. Now, what Ptolemy did was he joined the ends of these two radii like this. And then he calculated the length of this line in relation to that angle. And he said if you have that angle, you'll have this line length. What is this line length? It's a chord. Okay. Now then, if you take that chord and you divide it in half, this is we're dividing it in half by the diameter of this circle, what are you going to get? You're going to get 2 right triangles. That's what you're going to get. Now, since this has been divided evenly, this is a 30-degree angle, and so is this. This angle's 30 degrees, this angle's 30 degrees. Now, what did I tell you about unit circles? Okay, if you have a unit circle, you can calculate the length of this line. The length of this line is what? Sine. That's right, the length of this line is sine. But what is this the sine of? Is this the sine of 60 degrees? No, it's the sine of 30 degrees. When you chop this chord in half, you get the sine of 30 degrees. That's what you get. Now, how does this all debunk what I was talking about in that last video? Alright, we're going to go by chord length instead of by sines to start getting our numbers. Okay, if we do so, then what we'll have, if we draw this, and do you remember me telling you that there were no negative angles way back when in Ptolemy's time? Okay, so we can actually say if this is a 60-degree angle on this side, this will also be a 60-degree angle on this side. That wipes out all those negatives. Okay? And so therefore, we can start seeing a brand new picture. If we calculate this chord length, okay, then we can calculate sine and therefore get rid of the vertical angle theory. That's gone. Now we can say, using Ptolemy's table of chords instead of the supplemental angle thing, because that's all gone. We destroyed that with Ptolemy's table of chords. We can use this to say that the cosine of A is equal to the negative cosine of A. Why? Because of chords, not sines. That's what you need to know. That's why we can disprove the supplementary angled bit and the vertical angle bit, the whole 9 yards. We're now going to calculate chords instead of sines, and by doing so, that goes away. You see what I mean? Now you can use Euclid Book 2 proposition number 12 and Euclid Book 3 proposition number 20 to start calculating your sines, your cosines, your tangents based on that chord theory. See what I mean? Say goodbye to those tiny little acute angles, because they don't exist anymore. Alright, hopefully that helped you out. I will tell you more in a future video. Stay tuned.